All right, welcome back. This week we are starting a new unit on something called polynomials, and we're going to focus solely on multiplying polynomials. And the first thing we have to be able to do in order to multiply polynomials is we have to be able to multiply monomials. And so that's what we're going to do today. And so one of the things you need to know is what is a monomial. A monomial is, I can't even say it, a monomial is a single term. And when I say a single term, I don't mean a single number or a single variable or anything like that. I mean a single group of numbers and variables that are multiplied by each other. So for example, where it says draw it out, show what is meant when you multiply 5x to the third times 6x to the seventh. Well, the 5x to the third is a monomial, and the 6x to the seventh is also a monomial. Okay, so you can see there's more than one thing that's part of a monomial, but everything that's inside of the monomial is being multiplied together. All right, there's no plus signs, no minus signs. All right. So it says show what is meant when you multiply 5x to the third times 6x to the seventh. Well, here's what's meant. What is meant? That's a kind of a strange word. So what is meant by that is we are going to multiply the 5 times the 6, and then we are going to multiply the x to the third. Well, any exponent means we multiply something by itself. So x to the third actually means 3 x's. So we're going to say times x times x times x. And then x to the seventh is 7 x's. So we're going to say 1, 2, 3, 4, 5, 6, 7. And right away you can probably notice this is something that we don't want to have to do all the time. So we are going to show you a way to do this without having to write them all out like this. All right. So again, this is the x to the third, and this is the x to the seventh. All right. And so what you'll notice is that I've rearranged things. I've put the two numbers next to each other, the 5 and the 6. We call those numbers coefficients, and they are next to each other because we're going to multiply them together. So when we multiply them together, what we get is 30, right? Why does my finger keep drawing on here? All right, so 5 times 6 is 30. And then since we have all these x's here, what I'm going to do is I'm just going to write 1x, and then I'm going to count the number of x's. And I have 1, 2, 3, 4, 5, 6. Oh, here, let me put little numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to say x to the 10th. All right, so I just showed what is meant when you multiply 5x to the third times 6x to the seventh. Okay, we multiply the two coefficients, 5 and 6, and then we multiply the two variables with exponents, but each one of those exponents means we have a certain number of that variable, and so in this case we end up with 10 of them. So hopefully you can notice that the 10 is just 3 plus 7. So when we multiply anything with exponents, we just have to add the exponents together. So that's going to save you all the effort of having to write all of these letters out and then count them up. Okay, so I can just look at that and say x to the third, x to the seventh. Well, 3 plus 7 is 10, so it's x to the 10th. All right. So I think the first question here, what happens to the exponents when you are multiplying? Well, what happens to them is they are added together. All right, the exponents are added together. All right, and I can even show you here. So we have x to the third times x to the seventh equals x to the 3 plus 7, or x to the 10th. All right, so that's the example of what happens to the exponents when you are multiplying. You add them together. All right, one kind of random question here, or one random thought here is, even if you can't see it, an x by itself has an exponent of 1. All right, so if I have an x here all by itself. One thing that people forget is that there actually is an exponent there, and the exponent is a 1. So when we're multiplying, we have to remember to add that 1 to whatever other numbers we have, okay? All right, so let's just go through these 3 examples here, and I think once I start going through it, hopefully you'll start to get it. All right, so 3x times 9x. Now this is right away, we're jumping right into this idea of, hey, an x by itself has an exponent of 1, and I see 2 of them there. And so I'm going to do 3 times 9, and 3 times 9 is 27. And I know it's going to have an x, and I just have to add the exponents. So 1 plus 1 is 2. So I have 27x squared. All right, let's do another one. Negative numbers, perfectly fine. All we have to do is remember that a positive times a negative is negative. So 5 times negative 4 is negative 20. All right, again, we have a situation where we have an x by itself. So there's an exponent of 1 there. And we want to add those 2 exponents together. So we have x to the 1 plus 2, or 3. So x to the 3rd power is what we say. All right, and the last one has no coefficient in front of the first x, at least one that we can see, right? We know there's a 1 there, so I could go ahead and put a 1 there. And it's not going to change my answer at all, because if I had no number there, I would look at the 4 and say, well, I'm going to write a 4 no matter what. And I'm still going to write a 4 with that 1 there, because 4 times 1 is just 4. But then you should notice we have 3 for an exponent on the first x and 4 for an exponent on the second one. So the 3 plus 4 is 7. So we have 4x to the 7th. All right, your turn. You got 3 of them to do there. And so remember, the red boxes with the numbers means you're going to be entering these in Schoology. And when you are done with those, turn the video back on, and we'll go over multiplying something a little bit more complex. All right, so in the first 3 examples, and the first 3 that you had to do, all we were doing is multiplying 2 monomials together. And now what we're going to do is we are going to multiply a monomial, so this is a monomial, by a trinomial. This is a trinomial. And the cool thing about a trinomial is it's just 3 monomials either added or subtracted together. In this case, we're adding the first 2, we're subtracting the last one. And these are all unique terms. They're not like terms, so we can't combine them together. Some people want to try to combine them together, but we can't. And so what we're going to do is we're going to do the exact same thing that we just did, but now we have to do it 3 times. So I'm going to multiply the 3x times the 2x. I'm going to multiply the 3x times the 7x, and the 3x times the negative 1. All right, so I can write this all out. So I can say 3x times 2x squared plus 3x times 7x, and then minus, I'm going to write that minus because of that minus sign right there, minus 3x times 1. Okay, I could have done plus 3x times negative 1, but either way, it's about the same. All right. So then now you can see I have 3 monomials I need, or 3 sets of monomials that I need to just multiply together, right? So the first one, 3 times 2 is 6. And then remember, there is a 1 for an exponent on that first one, so it's going to be x to the 3rd, because 1 plus 2 is 3. And then we have 3 times 7 is 21, and there are 1 and 1, so we have 2, right? So that would be x squared. And then anything times 1 is just itself, so 3x times 1 is just 3x, so we're going to say minus 3x. All right, so there we go. We just multiplied a monomial by a trinomial, and the key thing to remember is we just have to do it 3 times. Let's do another one. Ooh, we got 3 of them to do. All right, now you might start to get into the habit of maybe skipping some of these steps a little bit, and that's okay if you're capable of keeping track of it. And we could try this one where we just say, all right, 5x squared times 10x squared. Well, 5 times 10 is 50. X squared and x to the fourth, I see 2 and 4, so that's 6. Okay, and then I'm going to put a plus sign. 5 times 9 is 45. X squared, x to the third. I'm going to add them together, remember. The biggest mistake people make is they multiply them. So we want to add them together, so we have x to the fifth. And then we have 5x squared times 2x squared, and there's a minus sign there, right? So that's going to be 10x, and I see 2 plus 2 is 4. All right, so there we go. We could even do that, where we kind of think through it in our head. And then there is another method that we could use if you want, and you're free to use any of these. Whatever works best for you. And this last one is something that we're going to use in the second lesson this week. And to me, I really like this method because it keeps us organized, and it's called the box method. All right, so you'll notice that I started off by putting 7x to the fifth out front, and then on top of these boxes, I'm going to write negative x, and then notice I'm not going to put the plus sign there. So I'm just going to say 5x to the third, but then I am going to put the minus sign because it's making that a negative 4, right? So I'm just writing the terms there with whatever sign they would have if they were by themselves. Okay, so the first one's negative x, the second one's positive 5x to the third, and the last one's negative 4x to the fifth. All right, and so this is called the box method. And the box method keeps us organized because it shows us that, hey, we're going to multiply. We're going to have 3 answers after we multiply, right? I'm going to go through and I only have to do, well, I could do this. I could add a 1 here and a 1 here, right? But otherwise, everything else is okay. There's no other things that I need to add there. So the first one, I'm going to take the 7x to the fifth and multiply it times the negative 1x to the 1. All right, so this becomes negative 7x, whoops, that's ugly, to the 6th, because 5 plus 1 is 6. Okay, the second one, 35x to the 8th. 5 plus 3 is 8. Okay, and the last one, negative 28x, and 5 plus 5 is 10. So we're going to have to the 10th. All right, so then I can write my answer. I don't want to leave my answer in this box. So I'm going to move it out, write my answer, 7x to the 6th. And now since the middle term is positive, I'm just going to write plus 35x to the 8th. And then since the last term is negative, I'm just going to write minus 28x to the 10th. All right, so there we go. Okay, so you have 3 to try on your own here. Don't let this last one confuse you. It has 4 terms inside the parentheses, so that is no longer a trinomial. That is now just a polynomial, because poly just means many. All right, so you should be able to do these 3, and when you're done with all these, make sure you enter your answers in Schoology.